Welcome to section 6.5, Factoring Special Cases. I hinted about this section in the lectures for 6.3 and 6.4 because these special cases really aren't that special. They're not things we haven't seen before, just perhaps in a different light. So first off, I want you to get warmed up by going back to multiplication. So I want you to pause the video and I want you to multiply those two binomials together. All right, so hopefully as you did that, you remembered you went back and you distributed. So we got a squared minus ab plus ab minus b squared. The middle terms cancel and left with a squared minus b squared. Okay, that's useful. So what about this one? Can you multiply a plus b, the whole thing squared? Pause the video, multiply that out. Well, again, first off, you should have written that as a plus b times a plus b. Then you can distribute, combine like terms, you end up with a squared plus 2ab plus b squared. Now there's the method to my madness here. I'm doing that because our special cases are two special cases. First off, we have what's called a difference of squares. Well, notice a difference of squares, when I have the very first example of a plus b and a minus b, I end up with a square minus a perfect square. So these squares subtracting each other, this is what it means to be difference of squares. And we multiplying already got this way, but an equal sign is a two-way street. So if I have this, it's going to factor into this right here. So I'm going to figure out what's being squared in the first spot, and that's going to go in the first of each parentheses. What's being squared in the second spot goes to the end of both parentheses. And one gets a positive and one gets a minus. And again, you can always check by multiplying it out. Our other example is a perfect square. And this is the one where we had where a plus b squared was this. Now, you can memorize this formula. My recommendation for the perfect square is, notice it's a trinomial, which means it falls in the category of what we did in 6.3 and 6.4. If I was you, I would spend less time trying to memorize that special case and more time just understanding how to factor in general. It will serve you much, much better in the long term of this course. And that would mean that you only have to focus on one special case, and that's the difference of squares. So let's do some examples. Notice this has three terms. If you want to use the AC method, you could. And we can look at 25 and say, what are the perfect numbers that go into 25? Well, 5 and 5 are in there. And 5 plus 5 is 10. Therefore, we can split that middle term, 5x and 5x, x plus 5, and x plus 5. Yay! And notice it's a perfect square. So the rule was, what's being squared here, it's x first. It's being squared here, 5. And notice this term is 2 times 5 times x. Again, there's so many parts you got to memorize for that. I would just recommend the AC method. Okay, so let's move on to some others. If we look at this off the bat, so notice I only have two terms. And the first question I would ask you is, are they perfect squares? Yes. Is there a difference? So is it subtraction? Okay, yes. So what is being squared? Well, x squared is clearly x being squared. And 9 is 3 being squared. Which means that inside my parentheses, notice x goes in the first spot, 3 goes in the second spot, and there's a minus and a plus. It really doesn't matter if this is plus and this is minus, or this is minus. There's lots of ways to, as long as one of them is subtraction, one of this is addition. And always the first ends up in the first, and the second ends up in the second. It's all the way it has to be. Let's do another one. 81x squared minus 49. So I want you to ask the question of what is being squared in each term. Well, hopefully you said the first term is 9x squared and the second term is 7. So with that in mind, can you break it apart using the rule, the difference of squares rule? Well, hopefully you realized it's 9x minus 7, 9x plus 7. All right, let's do another one. I have 25 minus x squared. Whew. This doesn't seem so bad. What's being squared in the first one? All right, go ahead and pause the video and work through this using the things we've already done, because I've already started asking the questions. I want you to finish doing it. So hopefully you looked at the first and said, okay, that's 5 being squared and minus x being squared. But notice, so the 5 ends up in the first spot and the x's end up in the second spot. X's do not always end up in the first spot. Don't just assume that. It's all order is very important when we have subtraction, so we got to keep that order. Again, you can check by multiplying this out. All right. What about this one? X squared plus 4. Well, I have two terms. Are they perfect squares? Are they a difference? Hopefully you recognize not a difference. These are a sum of squares, not a difference, which actually makes it prime. All sums of squares are prime. Differences of squares are not. So you got to keep that in mind. We still have that prime thing popping back up. So be careful. Don't just get into a robotic routine. You got to kind of understand and think about this. Okay, I want you to try this last example using difference of squares. Go ahead and pause the video and work through it. All right, hopefully you recognized that 3x is being squared in the first one and 8 is being squared in the second one. So we have 3x minus 8, 3x plus 8. All right, that is really the only key thing. And so whenever you have trinomials, again, I just recommend using the AC method. I'm not going to spend time hounding that rule because I think you don't need to memorize another rule. Just understand how to factor a trinomial and you'll be fine. So let me know what questions you have. Good luck with the homework.